take some time here to go through some problems from our textbook from section 2-4 overall. So we are going to start off talking about our parallel lines. So we want to remember that parallel lines will always have the same slope. So parallel slopes will always be the same. The perpendicular slopes will always be opposite reciprocals. And we say opposite reciprocals, remember we're changing the sign, positive, negative, negative, positive. Reciprocal will be flipping the fraction. That's the short version of it. Okay, so the first thing we have is problem 10, one of the even ones. We want a line in slope-intercept form that's parallel to y equals 3x plus 4. And it's going through the point 0, 9. Now, some of you can get this equation without much work at all. I know that the slope of the original line is 3. So that's good, I'm all set because it's already y equals, so the original line slope is 3. Any line parallel to that will also have the same slope. And if you look at this line, this point, this is my y-intercept. Remember, there's two facts we know about y-intercepts. One, it's on the y-axis, and two, the x value is 0, the y value is given here. So if I know that information, my equation is simply y equals my parallel slope 3x plus 9. That is actually b. So I want to point that out, that there's not much work I have to do. Now, on a typical day, we might not recognize that this is an ordered pair that is a special y-intercept. We would not realize that that's actually b, so we would go through the steps to do this. So I'm going to go ahead and do this example in point slope form. And again, you can pick either form. So I've been showing both forms. I'm going to show this one in point slope form. So I have my y minus y1 equals m times x minus x1. So we are doing the same thing. What's different is I'm giving you a line and you pull the slope from the relationship that parallel lines have the same slope. Once I take the slope from this line, I don't go back to it. I am using this information to build my line, so we're back to where we were. So I would go with y minus 9 equals m, which we know is 3, times x minus 0. So I have y minus 9, distribute that, I just get a 3x, and then I simply add the 9 over, and there's that same equation, 3x plus 9. And there you have it. So I also want to remind you that this ordered pair has nothing to do with this point. If I put 0 in here for x, 3 times 0 is 0, plus 4, I certainly don't get 9 out. This point is different. So I have a graph. If I graph this at 4, and I go up 1, 2, 3, and write 1, this is what my original line looks like. That's what the original line looks like. And then there's infinite lines parallel to it, as long as they have a slope of 3. But there's only one line that goes to the point 0, 9. So I'm at 4, 5, 6, 7, 8, 9. One point that goes through there, and it has the same slope, up 3 over 1. And that would be my line parallel to this. So this is my anchor point that I plugged into the formula, and then I use my parallel slope to create this line. So this point has nothing to do with this line. It's my anchor for my line that's parallel to it. Okay. Now, looking at the next one, we have another parallel one. I want to get the even problems done on this homework. So we have another one that's parallel to y equals negative 1/5 x minus 2, and it goes to the point 2, 3. So the slope of my original line is negative 1/5. So the slope of any line parallel to that is also negative 1/5. So I'm again going to use this information. I am not using anything else from this line other than the slope must be the same since it's parallel. All right, so this one I'm going to go ahead and do y-intercept form, and that would be using y equals mx plus b. So you choose the method that works for you, and I'm going to take this, I'm going to plug in everything I know. So this is my x and y, there's my m, so 3 is equal to negative 1/5 times x plus b. All right, now this one's not canceling out, so I have a negative 2/5 here plus b, and then I'm going to add 2/5, and b is equal to 3 2/5, or we can change that out to be 17/5. Remember that shortcut, 3 times 5 is 15, add on the 2 parts. So my equation would be y equals a slope of negative 1/5 times x plus 17/5. Or you might have this written as 3 2/5. And that is your answer. Okay, now I don't have any perpendicular ones on here, but if I asked you for a perpendicular line through the point 2, 3, you're going to do the same procedure, but if the original slope was negative 1/5, your perpendicular slope would be a positive 5 or 5/1. And so we would use this information. So even though this was not the homework problem, I wanted to point out that if it was perpendicular, we use the opposite reciprocal slope, and we go through the same procedure. It'd be 3 equals a slope of now 5 times x is 2 plus b. And so now that we've got that, we would solve and get b equals negative 7. So if it was perpendicular through that point, it would have a slope of 5 times x and then minus 7. So this would be a line that is perpendicular to y equals negative 1/5 x minus 7 through the point 2, 3. And it's just a coincidence that they have the same y-intercept. That means they intersect there. Okay, so your problem was just parallel. I just want to show an example with perpendicular. All right, this one is a problem that we did some work on in class. You're given 2 lines, and we need to determine if my lines are parallel, perpendicular, or neither. So the only lines that are parallel have the same slope. Parallel lines will never intersect. If they're not parallel, if they don't have the same slope, they're going to intersect. So the idea of neither just means they're not parallel and they're not a special relationship of opposite reciprocal slopes. So parallel, same slope. If there's a special intersection at 90 degrees, opposite reciprocal slopes, we would list that. And otherwise, they're just 2 lines that intersect. All right, so looking at this, they're both y equals. You want to have proof. So you should have on your paper m equals negative 1/8. Prove to me what you were looking at. M equals 8. So now that I see these are the slopes that they're comparing, these are the slopes I want to compare, I can tell you that these are opposite reciprocals. So opposite reciprocal slopes means that they are perpendicular. So that would be my answer. And you could write out the word or use perpendicular. Okay, now 31 is actually an old problem. 31 is going over just writing the equation of a line, not parallel or perpendicular. So I thought it was good to throw this back in the mix. So in this problem, I need to find the slope before I start. So that's my first step, and that is going to be m equals, and I'm going to start here, so negative 4 minus 7 over 3 minus a negative 5. So watch that negative sign. In the top, I get negative 11. In the bottom, I get 8. So not the prettiest slope. I get m equals negative 11/8. Now that's my slope. I still need to write the equation of a line in slope-intercept form. So I'm going to use my slope of negative 11/8, and I'm just going to go ahead and pick the point 3, negative 4. So you can pick either point. And I'm going to go ahead and plug this into y equals mx plus b. Again, you can use point slope. So here's everything I need labeled. This gives me a template. Put my negative 4 in here for y. My slope is negative 11/8. My x is 3, and b is what I'm looking for. So I'm going to go ahead. I want to keep this as a fraction, so this is going to be a negative 33 over 8 plus b, and then I need to add 33/8 to both sides. Okay, so a little bit messy there, sorry. I get b equals, and we have a negative 4, and we're adding to it 33/8. So you can put that in your calculator, and you'll get out an answer of 1/8. So my equation is y equals my slope of negative 11/8x plus 1/8. So that is my equation. Now, just in case you're wanting to practice this, how do I add negative 4 and 33/8? How do I add that? Well, you need to build yourself a fraction, and in order to add fractions, I need a common denominator. And even though we have calculators, we're eventually going to need to know the rules of fractions because we won't be able to put everything in our calculator, especially when it comes to building rational expressions and equations. So we start practicing now. To add or subtract, I need a common denominator, so I multiply this by 8 and multiply this by 8. So I really have negative 32/8 plus 33/8, and if I add that together, I get 1/8, and there is my y-intercept. Okay, so that's a little bit of review for you. I have one more problem to go over. In number 33, they gave us a table of values. So I can find the slope a couple different ways, but I'm really going to do number 33 exactly like I did number 31. I'm going to pull, if this is a linear relationship, I can pull any two ordered pairs. So I'm picking to pull 444 and 128. That's what I'm picking to pull. So if I go ahead and do that, I would take 128 minus 44 to find my slope. And then I would take 8 minus 4. So y's over x's, change in y over change in x. All right, that ends up giving me 84/4, which ends up dividing out to nice 21. So I have a slope of 21, and then I'm going to pick one of the ordered pairs. I'm going to pick 444. You can pick either ordered pair. I just like to pick the one with smaller numbers. I'm not going to pick decimals. I'm going to avoid negatives. Okay, with that in mind, in this problem, I'm going to go ahead and show it in point slope form. Again, you can use point slope or slope intercept. So here we go, y minus y1 equals m times x minus x1. So here's my x and y. So y minus 44 is equal to my slope of 21 times x minus 4. Y minus 44 equals 21x minus 84. And then I would add 44 to both sides. And there it is, y equals 21x minus 40. That is the equation of my line. Now, the other way I could have found the slope was by looking at the change in y and x. So I would take 7.5 and take away that 4, and I see that I have a positive increase of 3.5, but this one jumps only by 0.5. So if we look at the relationship here, 117.5 take away 44, I get 73.5, and here I get a jump of 128 minus 117.5, I get what, 10.5. If I take the ratio of 10.5, the change in y over 0.5, I would divide that out, 10.5 divided by 0.5, and we do end up getting that ratio to be just a 21. If I would have taken 73.5, the change in these y's over the change in these x's, and I take those numbers and divide them out, I will also get a nice even 21. So I could have found the slope by looking at the constant, looking for the ratio of the change in y over the change in x, or simply pulling 2 points. And then once I get that slope, then I am down here to find the equation of my line. So in all these problems, whether you're talking about just writing an equation of a line, you're writing parallel or perpendicular ones, your first priority is to find the slope. The next priority is to find, am I using this slope, or am I looking for parallel, same slope, or perpendicular opposite reciprocal? And then you choose if you're using the point slope formula, or if you are using y equals mx plus b formula to do the problems.